Password authentication is okay, provided you create a strong, difficult to guess or crack password. We're going to look at key-based authentication and why that's even better. Here are a few examples of some passwords. These passwords, password and password with some special characters in it, are very bad, both because they're too short and based on dictionary words, and because many people use them. So the bad guys know they're used, so the bad guys use them and try to log in with them. Here are some better passwords. Sector is a security conference in Toronto. So you can substitute E's for threes, it's like a backwards E kind of. O's for zeros. Ones for I's. There are many substitutions you could try. But this password is pretty long. It has upper and lowercase letters, special characters like the hyphen, and numbers. Here's another passphrase. Ubuntu server remote admin. Passphrases can be longer, but they can be easier to remember. They can be sentences, lines from songs, titles of books, phrases from books. Pick something that's relatively easy to type and remember. Even a good password or passphrase, though, could be compromised. Compromises happen all the time, and if your email and password were stored on a server that didn't secure them properly, and that server was breached, your password and passphrase and the login you used could be out on the internet. Here's an email address I used many years ago. You can see that it's been in 8 breaches. So I used that for an Adobe login. And if I used the same password for other sites and the same login, those would be compromised as well. It's good not to reuse passwords. You could use a password storage utility like LastPass or KeyPass. However, we can avoid passwords and their problems for SSH login at least. We'll use Public Key Encryption. Public Key Encryption makes use of a public key and a private key. These will be generated for you, but the process depends on what utility you're using. We'll cover Linux and Mac first, and then go over Windows in a separate lesson. When you're using public key encryption, you'll have a private key that must be kept private and never given out. You keep it locally on the server that generated it. It's used to encrypt things that are being sent. You'll also have a public key. This may be given out when needed. It will be sent to the remote server, and it will be used to decrypt things that were sent. Here's what a public key looks like. You can see it looks like an amazingly long and complex password or passphrase. If everything is set up correctly, this should be practically impossible to crack. But it's also paired with a private key that looks very similar. It's also very long and random. These two are used together to encrypt and decrypt messages. In order to use public key authentication, you'll have to generate your keys. Linux provides a tool that makes this process easy called Ssh Key Gen. It's also used in Mac OS X and BSD. Typing Ssh Key Gen will generate your public and private keys and save them in the default location. My keys will be stored in home, username, which is Theo, in a hidden directory .ssh. And the files will start with ID_RSA. We'll accept the default by hitting enter. And please always put a passphrase on your keys. That way, if anyone is ever able to get your key somehow, they won't be able to use it without the password. So use this pretty strong password or passphrase. You'll be asked to put it in again. Put the same password in again and hit enter. And it saves the private key to home theo.ssh ID_RSA, and the public key is the same location with ID_RSA.pub. You don't have to worry about this fingerprint or the key's random art. This is just trying to show you that the key is kind of random and would be hard to crack. So if we do a ls alh on our home directory now, there's a .ssh folder. You can see the permissions are read, write, and execute for the user, but nothing for everyone else. So people can't even read what's in this folder. And the utility automatically set that up for us. And then looking at the files in the folder, we have ID_RSA and ID_RSA.pub. ID_RSA is also restricted. It has only read and write for the user and nothing for anyone else. ID_RSA.pub is supposed to be readable by others. If we look at the public key, that's what it looks like. There's a command called ssh copy ID, which will copy our key to the new server. It will use locally available keys to authorize logins on a remote server. So we'll type ssh copy ID, Theo, that's the username I used, at the remote server IP. We've never connected to this server before, so we get this message to just type yes. Put in your password. And your key was added. So it's telling us we can log in and make sure our key was added, so we'll do that. Put in the password for your key. And we're in. What happened when we did that was that our key was put into a file called authorized_keys. So you can see that's the key that we had before, the public key. So it automatically made this file authorized keys for us, and it made the correct permissions. If any of these permissions aren't set right, your login won't work properly. So using these automated tools did that for us. You may wonder, why all this extra security? Why would anyone attack my server? I don't have anything valuable on it. Unfortunately, attackers likely don't care who you are or what's on your server. There are people and programs constantly scanning the internet for vulnerabilities. They'll automatically, or through manual intervention, leverage those to compromise systems. I spun up a disposable server on DigitalOcean to illustrate this. This server was set up about 5 days ago. If we take a look at var log auth.log, which is where authentication attempts are logged, we'll see that there are a whole lot of people trying to log into this server. There's no reason anyone should log into this server. This is my server. I didn't authorize anyone to connect to this. This will happen to any device you have on the internet listening on port 22. You can see there are attempts to log in as root, foobar, many usernames. Let's see how many connections were attempted using invalid usernames. We can see that the word invalid is used in lines that have an invalid user. Oh, we have to use sudo. We'll grep for invalid in var log auth.log, and we'll send the output to word count -L, which will tell us how many lines. So there are 1,089 attempts. Let's see how many people tried to log in as root. 2,477. So people are constantly attacking your servers, trying to find vulnerabilities. In a future lesson, you'll learn how to disable password authentication so all of their attempts would automatically fail even if they knew your password. Until you do that, Ubuntu will automatically fall back to password if key-based authentication doesn't work. And we don't want that. So that's it for key-based authentication with Linux, and the procedure is the same for Mac OS X. See you in the next lesson.